Hey, and welcome to another episode of AT Banter.
Banter, banter.
Hey, this is, of course, the podcast where we talk with advocates and members of the disability community to educate and inspire better conversation about disability. Hey, my name is Rob Minot, and hey, look who else is here. It's Mr. Ryan Fleury.
Is that what we do here? We talk to members and organizations of the disability community to educate and inspire better conversation about disability?
Wow, yeah, you've got that memorized. You should get you to start doing it. I thought I was just doing it by default because I'm the only one who had remembered it.
Not bad, eh?
That's not bad. I'm impressed.
Excellent.
And I noticed we didn't do a trigger warning for the cowbell this time.
I know. I thought about it.
Did you?
My bad. Yeah.
Oh, well, no, listen, it's something we're experimenting with. So
I think we should just create an audio file and we can just play it.
we'll do some A/B testing. I don't know. I don't know.
Nobody's ever complained about the cowbell, saying it triggered them. So
Yeah. Well, so there you go. So maybe we're just
maybe
being
we're good.
Maybe we're we're overthinking it
Maybe.
because it's indicative of us. Hey, how are you doing?
I'm doing good. I'm excited this time of year because it's Black Friday week, so there's sales galore and
Yeah. So what's yeah? Tell me, have you bought anything yet?
I've bought just a couple electronic cables for guitars and pedal boards and stuff, but mainly Christmas presents. So,
All right. Well, let's dive right into the show because we've got a meaty one today. So, hey, Ryan,
me, Rob.
what the heck are we doing today?
Today we have a couple guests joining us from the company Kinemo. We have Dr. Nordine Sebkhi, who is the co-founder and CEO. And we have Arpan Bhavsar. I hope I pronounced that right. If not, my apologies, but welcome to both of you.
Thank you guys for having us here. We're pretty excited to talk about Kinemo.
It's great to have you.
Why don't we just start out with just giving us a real broad overview of Kinemo and the specific types of products that you guys develop.
Yeah, for sure. So what we're doing at Kinemo is like we're developing wearable assistive technology to help people that cannot use their hands to control their devices. We enable them to use all the part of the body that they can still move to control their digital devices, drive their wheelchair, all these sort of things. So that's the core technology that we are developing at Kinemo.
And so, could you speak a little bit to your particular background and how you sort of landed in this particular field of assistive technology?
Yeah, for sure. So my background is in electrical and computer engineering. I was a researcher at Georgia Tech working on wearable body motion tracking systems. So that was my PhD thesis. And so we work in a lot of medical applications for that. But one that really stuck with me in Arpan was when we developed a prototype to help people that were in poor wheelchairs to be able to drive their wheelchair using wearable, sensors. And so when we saw the smile on their face, and when the parents of some of those participants that we work with really came to us and say, yeah, thank you for trying to develop something new because they have been using, the same old technologies for a while. Thank you for trying to bring innovation. And so this is why we decided, apparently this is something people want to see, and let's focus on that and let's turn our research work into an actual device and product that people can get.
Yeah, I just want to add, it's really cool when when people always ask that question about how'd you guys start. It's always fun to think back about our first, prototypes with this thing, and it was ugly and big, and it was wearable, but it was like a huge headset that you had to wear, and even with that kind of device, like Nordine said, people still really like the idea and like that it was something wearable and just a brand new way to control the technology around them, whether that was their digital device like their phone or computer, or if it was driving their power wheelchair. Also, they can be a lot more independent than they currently were.
Well, it's interesting too, because, especially within assistive technology, and Ryan and I have both sort of been been involved in AT for quite a while, and you're absolutely right. Innovation isn't necessarily always um, top of mind in the field. Like there's a lot of technology out there that's still pretty old and clunky, and nobody has really sat down and really thought about how do we modernize this, or how do we make this better, or how do we innovate? And I imagine that's because it's such a niche market, and there's only so many R&D dollars that people want to put into new devices. So it's always really exciting whenever we hear about a company out there that is trying to innovate and is trying to sort of move the football forward down the field when it comes to this, because there is a lot of really exciting new technology that's around. So talk to us a little bit about exactly what you guys are working on in terms of what is the innovation within this wearable physical access market?
Yeah, so what's really unique and innovative about our Kinemo technology, it's not one thing specifically, it's more the fact that we were able to put together things that exist out there, but in a way that it's customizable, practical, and more usable for the end users. So the core technology really, it's mixing some hardware component like the latest inertial sensors. Those are your accelerometer, gyroscope, magnetometers, all of those latest chip sensors. So we were able to put that into a very small package. And the other part of it is the algorithms, processing those data in a way that detect body gestures, which is a very, very difficult problem, detecting or detecting, sorry, the in user intended body gestures versus just natural body movement. It's not an easy problem to solve. Okay. So that's really where we spend a lot of time, is trying to develop those algorithms that's trying to do a better job to get exactly what the gesture the user want to do in order to control the devices. And because our background is also in hardware development, so I don't know if it's unique for our team, but that's something you might not see as often. It's people that have the skills to build their own hardware in addition to program their own firmware and the software. Okay. So being able to do all of that just ourselves makes it that we can really customize our solution to the particular needs of the patients and the clinicians, of course.
Yeah, and just to add a little bit to that, so what that really means for us is that we're able to provide um, essentially wearable devices that have these small sensors. And I wish we had our video on because we can show you how small these things are. But the sensors are about the size of a fingernail. And what that allows you to do is put these sensors in really inconspicuously on different parts of the body that a user might still have remaining motion. So that includes, for example, we work with a lot of spinal cord injury patients, so we can put sensors on the head. We can put it on the shoulders, or even for really extreme cases, we can put it on the cheek or the eyebrow, so really facial motion even. So really where anyone has any sort of visible motion, we can place these small inertial sensors and then pick up the motion of the user and then turn that into usable input controls. So one example is you can turn the head into a joystick, and now your head can either control a mouse cursor or drive a power wheelchair. Or you can put these sensors on a shoulder or a cheek, and any sort of body gesture, like Nordine mentioned, if they're intended user gestures, then we can map that to certain discrete actions like mouse clicks or changing the modes of a wheelchair and really replacing the physical push button switch into a wearable switch that responds. It's essentially a zero force switch. It will respond exactly to the amount of range of motion that the user has. So it's fully customizable. The sensitivity is adjustable to the user's range of motion after their injury or with due to whatever condition that they may have. So that's really the innovation that we have, is a fully customizable, inconspicuous form factor wearable device.
Do your sensors use Wi-Fi or Bluetooth, and do you run into latency issues with, the control access of devices?
Yeah, that's a really good question. So the sensors are actually wired to a main controller. And the reason we do that is so the sensors can be really, really tiny. That way the sensors don't have a battery or an antenna inside it, and our controller has all that stuff packaged in it. And then for your question about connectivity, it connects via Bluetooth to different devices. So any device that accepts a Bluetooth mouse and keyboard will also be compatible with our device, and then that's how that communicates. And there's very little latency. I wouldn't say you would use this for any like competitive gaming or anything like that. But for everyday use, the latency is more than enough for most users.
So we're still waiting for that Call of Duty solution, really, for people
For
to
sure.
play. Yeah, fair enough. No, but
Definitely.
what stands out to me about this is that it's that customizable piece because that is really important, and especially in within physical access and mobility aids, because nobody's needs are necessarily the same. Nobody's injury is necessarily the same. So the ability to have the system that you can make work regardless of how much a range of motion that you have, I think is really powerful, and that is a really important innovation that really stands out to me.
Yeah, indeed. I think you are getting this perfectly. What we're trying to do with our device is a lot of things you see out there, they are very good, but they usually target one body part. Okay. And the problem is, for example, we work a lot of people with spinal cord injury, like Arpan mentioned, and a lot of them still have shoulder movement. Okay. That's a body gesture that is not being tapped by other devices, right? Uh, so this is where we wanted to be, listen, let's have a technology that no matter what they can move on their body, even if it's a toe, right? Let's have those sensors being able to adhere to that body part and use that body part for them to control devices. Okay, so that versatility, that's a lot of clinicians use that word, that our device is very versatile. And they really love that because, like you said, the patient needs are very different. I mean, what they can move on their body is very different. But what they want to do, what they want to control is also very different. So we wanted to have a device that is customizable as the input, but also customizable as the output, right? So something a feedback we got a lot from clinicians is, can you make an app that is very simple to use? Okay. It's a bunch of sliders, simple things, and making it that we can customize the output of the device, meaning what type of actions the patient can do on a device. And so we listened to that feedback and created an app that we try to make it as simple as possible that any clinician, but also any caregiver can use without having an extensive training on how to use it.
So would they also then be able to control the sensitivity of the device?
Yes, yes, indeed. They can control how much sensitivity their body movement needs to be. And even more than that, they can control also the speed of that movement. So some people, it's not a problem of sensitivity, it's a problem of how fast they can move a body part. And so you can control that too. So both of them, sensitivity and speed. And we made it that caregiver can do it on the controller itself. There is some buttons on it that they can adjust that sensitivity because the feedback we got is that some patients will start a day with a high sensitivity, like they can move
Hmm.
a certain body part very well, but they get fatigued, throughout the
Right.
day. And so there should be a way to make our system more sensitive, you know, as they lose that movement. Uh, but in the way that the caregiver doesn't have to open our app and change that. So having just physical buttons on the controller, it's something that they really like to have. How can we speed up any setup configuration for the caregiver. That's one of our goal.
And I would think too, being able to have the device decipher between an intentional movement or a spasm or a tick or something is vitally important.
Yeah,
Yes.
definitely. Yeah, so the sensitivities are the best way to delineate between an intended gesture and a, just someone moving around in their wheelchair, any other unintended motion. But that is a problem we're still actively trying to solve. And how do we make that even better? Because reliability is so, critically important, especially if someone's using this for work or when they're driving their chair, it needs to be safe.
Right.
Or if they use this for one use case is to use it as a attendant call button to call their caregiver. And if that's not reliable, then you have some implications there. So
Mm.
that is something we still actively are improving. But today we do have something that we believe is good enough for a majority of use cases where either the sensitivity is good enough to filter out these unintended motions, especially if someone has a light tremor or something like that. You can turn down the sensitivity so it only picks up large intended motions.
Right.
Again, this is all dependent on the condition.
Hmm.
And then we have, a procedure outlined in our user manual that goes through, this is how you would set that sensitivity so that we do make sure we get the most reliable sensitivity level for that user.
Right. Again, brings you back around to customization and how important that is.
Yeah, and honestly, you guys sound like you were part of our team from the start, like a couple of years ago. The way that you guys knew exactly the problems that we heard about is that there isn't a one solution fits all, and we heard that loud and clear. So we wanted to make something that was fully adaptable and can work for many, many conditions.
Yeah.
We talk about the fact that we work with spinal cord injury patients the most, but that doesn't mean that this won't work for ALS patients,
Hmm.
MS patients, muscular dystrophy, so on. There's so many conditions, really. It's anyone who has a need for a hands-free controller and use other parts of their body to control things. That's what our device is meant to do.
Or lazy people like me and Rob.
Yeah, that works too.
But no, I am really fascinated by the idea of reducing the number of different pieces of AT that somebody who does have physical access needs might have to deal with on a daily basis. In the past, you might have a series of switches. You're probably going to have something that's for your wheelchair that you have to access, that you have to use to do that. They might have some sort of a wearable, like a head gaze system or some sort of a head array, something to help them access their phone or their tablet, if they're into AAC, and then maybe even something else for computer access. So, you put all those together, and these are all different manufacturers and different types of AT that sort of all have to work together. Not only that, then you have the caregiver that has to be trained in it. You have the user that has to use it, and all of that can really drain their own, physical and emotional battery when they're trying to juggle all these things. So, you can't really understate the importance of trying to reduce the amount of things that the both the user and the caregiver have to fight with on a daily basis.
Uh,
I couldn't agree more. You hit you hit the nail on the head. That is incredible.
yeah, yeah. So a feedback we got a lot, especially with those physical switches, is the fact that you have to position them perfectly for a patient to be able to reach them, right? Of course, we're talking with people with a high level of mobility impairment. So they have these physical switches. If they move on their wheelchair, let's say, we work a lot of people that are on the wheelchair, but this can be also on the bed or any other places. There is those physical switches, sip and puff, physical push buttons, all of that. The problem is all of those requires precise placement, right? If the user is moving a bit, even if it's like few, I would say 1 centimeters, right? Then they might not be able to reach those buttons, right? So that's a big problem because the caregiver has to always be looking around and making sure that the patient is still able to reach their input control. So it's taking a lot of time that the caregiver can spend on doing something else, you know. So this is also something that we found out that we are solving by having a wearable device. Is that now it doesn't matter where the user is. They can be on the chair, they can be on the couch, they can be on the bed. Uh, it doesn't matter. They can be moving around, doesn't matter because those controls are on them, on the body. And that's a big difference than a lot of existing solutions that exist out there.
And just to add to that, to the other point, Rob, that you mentioned, a caregiver does, a user may have multiple setups for each of their devices, their computer, their phone, their wheelchair. And another feedback we heard is that when you have all these devices, every time a user wants to change between, let's say, driving into their home office and then change to controlling their computer for work, and then drive back out of the room later for lunch or something like that, the amount of time needed by a caregiver to do all that switching is immense. So a really cool feature of our device is that it allows the user to independently switch between up to three Bluetooth devices and their power wheelchair. So they can independently now go from controlling their phone, their computer, and even if they have a tablet or second computer or whatever it is, and then also switch to driving their chair all by themselves. So that way we're not only trying to increase independence for the user, but also reduce caregiver burden so that they can go back to doing more important things, and not having to do all these, trivial tasks of putting on a device for their computer and switching over and setting up their head array for their power wheelchair, for example.
So I'm fascinated by the idea of what's called proportional controls and discrete commands. Could you guys speak to that and how you made the decision to sort of roll that into the design?
So yeah, so the distinction, just to make sure that your listener understand, is proportional control versus discrete command. Proportional control means it's emulating basically a mouse or joystick, right? It's something that the more you move, you can move in two directions, right? To move a pointer on the screen, or to drive a wheelchair forward, backward, left, and right. So it's that mode of control. Uh, Discrete commands will be clicks, press of a keystroke, and pushing a push button, those kind of things. So those are distinctive controls. What's good with our system is that we decided from day one, hey, we're going to use the same sensors, right? Let's not do something where we have different sensors for different way to control the devices. It's the same sensor. Now it's how you process the data from the sensors will be different if you want to do proportional control or if you want to do discrete control. But to really control a device fully, you will want to have both if you can. Okay. Because now you can move your pointer and you can click, or do other these actions. So that's basically what we wanted to do, give them the option to do both with the same device, the same system.
Yeah, and to add to that a little bit, our device, the Kinemo Connect, allows up to three of our sensors to be plugged into it. So a user can have, we typically recommend one of those sensors, one of those inputs out of three to be a proportional control. And then the other two, up to two more, can then be discrete actions. And you can use that for a variety of actions. They can be as simple as just pausing or resuming control of the device. Those discrete actions could be commonly it's used for like a left click of a mouse button on their computer. And then each device that they control that can be mapped entirely differently too. So that's where it can get really powerful. So maybe on their phone, they want one of their discrete actions to maybe go home or go back or lock their device. Versus on a computer, you might want your discrete actions to be a left click and a right click. So all that stuff is fully customizable, just the way the user would want it to be.
Yeah, and something I wanted to add is that proportional control, it's not only the head. I know for a lot of patients that are using assistive technology, I would safely assume majority of them will use head to do proportional control. However, again, because a sensor can be placed anywhere on the body, you can use your foot if you cannot use your head for whatever reason, right? We do have people that the head movement is limited. The injury or their neurological disease prevent them from moving the head in a way that they can control. It's a mouse cursor, right? But they still have a good foot movement. It will be hard for you to find a solution out there that can use the foot as a joystick. You can physically put a joystick behind their foot and they can use that, but it's very bulky and not as practical. So the idea is, hey, if they can use their foot, let them use their foot if they prefer that. But if they want to use the hand, we do have people, users of our Kinemo, that they cannot really move their arm, so they can't go and use a mouse or joystick, but they can still move the hand. Just they just cannot move the arm. So we just put our sensor on the hand, and they can use the hand to move that mouse pointer and even drive their wheelchair. Okay. And what's good with that, it also enables us to help other individuals that might not be our core target users. For example, there is a big push on the VR AR industry, right? Trying to get those headsets out there for work or for entertainment. And so what we also want to do with our technology is to be able to get people that still have hand control to be able to use input control with the hand on the AR VR devices. Okay. And this is where, a lot of technology starts on the assistive technology industry, but then naturally they progress to other industries that are not accessibility, oriented. So that's the kind of, I think the thing we're looking at with Kinemo is helping people that have mobility challenges, but over time take this technology and having other type of people that are maybe fully able-bodied, but they want to use, the hand movement to control things on their VR applications.
Yeah, and again, this really speaks to why that whole customization piece is so powerful. And we've seen it for years. I mean, there have been AT devices, very niche that, yeah, specifically worked with, say, the foot. And that's all it did. And of course, for a user, not only, again, you're going back to yet another device that they have to get to work with all of their other devices, but then there's also the cost and all of these. When you have a very niche piece of AT, that it tends to be very expensive.
Hey, podcast listeners. Steve, president and owner of Canadian Assistive Technology here again. While we love connecting with you online and over the phone, sometimes there's no substitute for seeing things in person. That's why we're so excited about our storefront at Unit 106, 828 West 8th Avenue in Vancouver. Coming to our showroom is a great way to explore many of the assistive technology solutions we offer. We're proud to say it's the largest assistive technology showroom in Western Canada. You can get a first-hand look at our extensive product line and speak directly with our team, who are happy to answer your questions and help direct you to the right solution. We always want to ensure the device you choose is the right fit for you. So if you're in the Vancouver area or planning a visit, we encourage you to drop by our storefront. It's a fantastic opportunity to see how Canadian assistive technology can help you meet your needs. We look forward to seeing you there. Again, the address is Unit 106, 828 West 8th Avenue in Vancouver. And now, back to the show.
So let me talk to you guys then a little bit about the development. How challenging was it to sort of enter this field where there are all of these pieces of AT? Was it a challenge?
I think the biggest design challenge with this was actually more the form factor, because what we were able to do, which was kind of nice, is on getting it compatible with most devices, we were able to tap into existing protocols. So we literally emulate a Bluetooth mouse and keyboard, which makes it really easy to be already universally compatible with most devices. So the biggest challenge was really the form factor was one, getting the sensor small enough and practical enough to still put on different parts of the body. coming up with a system to be able to adhere it to any part of the body. So the way that we've, finalized that is that we have a reusable sensor and disposable, what we call stickers. And these stickers snap onto our sensors, and then they're skin safe. They include a skin safe adhesive that lasts on the user's skin or clothing all day long, and then they can dispose of that and then use a new one. So that system was another challenge. And then finally, I think we alluded to this before, the development that went into coming up with the gesture detection algorithm was probably the most complex part of this all. Trying to filter out the unintended gestures was super difficult, and you can imagine. I mean, we now are able to support, virtually any part of the body, but that wasn't always the case. So getting to that point where we really could put this on many, many different parts of the body, shoulder, elbow, finger, eyebrow, jaw, cheek. Nordine even mentioned the toe, really anything that can move. Getting to that point was probably the biggest challenge.
Yeah, and what I would add to that is what we are facing now after we actually develop the technology. It's what we call technology inertia, right? It's when we talk with clinicians, our challenge right now is to have them, they're used to a certain type of input control, right? Their entire career, I would say. And now it's coming with something new and having them kind of shift their mindset and adopt this wave of new wearable technologies. Okay. So that's really, I think, the challenge is we are in this inflection point where we are transitioning with what I would call traditional input control devices. Again, your push buttons, physical switches, head arrays, sip and puff, and so on and so forth, to this era of wearables, right? That requires a little bit different way to see the technology and how it works. And that's that education piece that it's challenging for us because it's a new technology in the market. They have not heard about it when they were going to school, for occupational therapy, physical therapy, ATPs, and so on. And so now we have to educate them about those new wearable technology and what they can do. So much new ways to control and configure and interface that that's now a job, not only to provide that technology, but to educate them how to use it and
Right.
what use cases they can use it for.
Yeah, we've talked a lot on the show in the past few years, obviously, and it's obviously something that everybody's been talking about. But this idea of AI and how AI has really impacted the assistive technology field in a lot of positive ways. I mean, I would argue that given how we are using AI in general society. I mean, I think that you can make the argument on both sides about that, but I think that nobody can argue that within assistive technology, AI is a game changer. And I can imagine how these algorithms that you're talking about that allows for a lot of this customization and that allows for the device to be actually trained. I mean, I can see that that's incredibly exciting, but I could also see how agencies and caregivers can be slow to adapt the technology. Is that kind of what you're talking about and what you're finding is that people are just a little bit cautious about so much change in so little time?
What you're saying, it's completely true. Yeah, when you talk about AI, it can make some clinician or caregivers or even end users a little bit, I would say skeptical, but also a little bit afraid to adopt that because they think it's going to be too complicated you have to be technologically savvy, which actually another problem, if you can prompt me in a bit talking about challenges we have with people that are not technologically savvy and how, sometimes is a challenge to explain to them how to use the technology. But what I was referring about the wearables is not about the AI part of it. It's more about the idea of a wearable input control, you know, having something on you
Right.
versus having you to push something or to act on something, right? People are used to push a button, right? They're used to sip or puff through the straw. They're used to do something physically, they have to interact with a piece of hardware. And now it's like, no, you do not have to interact with a piece of hardware with your body part. You just have to move it, you know? That's it. That's how you control things. So that's more that part that I think uh, is at the beginning a bit challenging, but once they try it and they do it, then they realize how more freeing it is to not have any of this clutter around them, right? When you look at pictures of people having head array, sip and puff, and push buttons on their wheelchair, on their bed, and whatnot, I mean, you see this amount of hardware clutter around them. And a lot of our users are like, this is the worst for them. It is to have that, not only for themselves to have this vision blocked sometime by all of these buttons, also by accident, pushing buttons. But another part we heard a lot, it's kind of deviating from your original questions. I'm sorry, I'm kind of
Oh, it's okay.
ranting on different direction. But a lot of patients told us that they don't want to be seen in public as as having that disability,
Right.
specifically when you talk about having a lot of hardware around the face, right? Of course, there are people, if you're in a wheelchair, well, you cannot hide it, but they want to hide that they don't have those actuators around their face, right?
Yeah.
And that's where also wearable devices and what we're doing with Kinemo, we are trying to make our device as inconspicuous as possible. And like this, you barely see that you have something on you. So when somebody meet them on the street, they really have to look close to be like, oh, you have those sensors on you, right? You have this little bit of wire, but it's really well hidden. It's kind of, when you see people on stage giving presentation, they have those microphones
Right.
that are color matched, usually to, well, not really color matched to their actual skin color, but
Yeah.
they are different colors. Try to hide. Sometimes you can barely see that somebody has a microphone on them.
That's right.
You have to be close to them and be like, okay, you do have a microphone on you. So this is what we want to do. The end goal is that you would not see much, on them at all. So I know that this is something a lot of patients told us this is important for them, and only wearable devices can give that to them. Because anything else that is around them, you cannot hide them. You cannot hide that hardware from them.
And that's really interesting too, because really that's sort of typical of, I think, the entire wearable market development over the past 5-6 years. That in mainstream as well. We've come a long way, and really now I think we're really starting to see that market kind of explode now that we've got things like, say, the meta glasses, for example, that people can just put on. And again, going back to that form factor and how important that is, you're able to put that into a device that's both very discreet and light, and doesn't really sort of impact any part of their daily life. And so it's really interesting how sort of the mainstream wearable market seems to be really mirroring the AT wearable market, and how I think finally we're really seeing both markets really explode.
Yeah, indeed. And what I will add to that discussion is that you can even look at the future. What will be the future? If wearable input control is now a mainstream device, the next stage, the future, will be implantable sensors, right?
Right.
Of course, you have your Neuralink, all of those brain-computer interface route, okay? But what we are thinking is, can you implant a sensor that you even don't have anything visible at all, right?
Yeah.
And those doesn't require an extensive surgery like you will have with brain-computer interface. It will be a subcutaneous, implantable sensor. Probably at that moment, it will be wireless, right? And you just implant that and you use the same algorithm, the same technology that we're using today. It's just you hide it even better by implanting those sensors. So that's kind of what I think even the future is going to be. And for people with physical limitation, they could now get access to technology that will be fully invisible and make them hopefully feel better because nobody can see that they have that input control on them.
But so then going back to Kinemo specifically, where are you guys going, say, in the next 5 years?
Yeah, so we really literally just get our first product out there, the Kinemo
Yep.
1 system. So in this next 5 years, it's going to be deploying our technology to as many rehabilitation centers and other point of care for our customer target population to North America, but also to the Europe and other part of the world, um, and trying to make sure that people are adopting these new waves of technology. Okay, so that will be the fire because it takes time. As you know, in this field, specifically with when you talk people with high level of physical limitations, it takes a while to get our system out there to clinicians, train, educate the clinicians, have them have patients to try this technology, adopt it. So it will take, a little bit of time. So
Yeah.
this is what we want to do in this next few years, hopefully not 5 years, if it
Yeah,
can be the
sure.
next 1 to 2 years, um, just get that out there and then improve the technology. For example, right now the sensors are wired. Okay.
Right.
Uh, we always had the comment, why are you not making your sensors wireless? It's going to be even better. The problem is because we are a startup, we don't have the funding and the team to miniaturize our sensors even further if you talk about the wireless.
Right.
Because when you talk about wireless sensors, you have to add a antenna, a battery, a way to charge them, a controller in them. There is a bunch of electronics and parts you have to put inside them that makes it much bigger than if it's wired, right? So that's why we started with a wired sensor, because we can make the sensor itself smaller.
Right.
Once we get enough funding, revenue, enough financial to build a team, then we can start miniaturizing it and get those wireless. And that will it's this in-between step between I talked about those implantable
Right.
um, sensors. That will be the in-between step between the wired, then we go to wireless, but still small. It's important for us that the sensor remains small. That's most important. So get to wireless small sensors, and that's hopefully is going to be within the next 5 years.
Yeah, and one more thing to add in 5 years. I mean, we've developed this technology, and it was in conjunction with people with disability, and it's for people with disabilities. But the nice thing about accessible technologies is that it really benefits everyone.
Yeah.
So, an easy example that I almost see every day is, door openers. Like in my apartment building, we have a automatic door opener, and I push that button all the time because I have, groceries in my hands or something. Like there are ways that able-bodied individuals will still use accessible technologies. Captions, for example,
Yep.
we use that all the time, right? I can't watch a video or a
That's
movie
right.
without subtitles anymore. So, um, what I'm trying to get at is that there are use cases for able-bodied individuals to also to also use a hands-free controller, and that's something we want to explore. For example, there are occupations in the field. You can think about surgeries or operating heavy machinery and construction where your hands are tied doing a critical task. And if there's a use case, then to use other parts of the body to operate something entirely different.
Yeah.
So there are other markets that we want to explore, and hopefully at the tail end of those 5 years, we can find and identify these markets where Kinemo can adapt into, not just for accessibility, but improving the functionality of some of these occupations where your hands are tied in something super critical.
Yeah, I know 100%. The dream is, actually getting out of this idea of assistive technology and just having that technology blended in with mainstream devices. The Meta glasses are a great example of that. I mean, Meta created this wearable that ended up being an incredibly powerful assistive technology tool for the blind or the partially sighted community without even really knowing it. That's where the future is this notion of universal design and having more universally designed mainstream products that can do anything for anybody.
Exactly. Like right now we have our mice and keyboard, and maybe in the future it'll be mice, keyboard, and body
Yeah.
control, something
Yeah.
like that.
Totally. Absolutely. Guys, we want to thank you so much for coming on. It's been a great conversation. If people want to connect with you or they want to explore a little bit more about Kinemo, where can they go and how can they reach you?
Yeah, they can go in our website, uh, and that's kinemo.io. Uh, Please just go there. There's a contact form. Send us a message, whether you are a person with a physical disability that think can benefit from it, whether you're a clinician that wants to get a demo of our system, whether you are somebody in technology, a company in technology that are interested to see how we can adapt our technology to their systems or devices. There is a contact form, please. We would love to talk to people and and see how we can help with our technology. But thank you very much, guys. I mean, this is great to have this conversation with people like you guys that are experts in assistive technology, get your thoughts and feedback, and helping startups like ours, very small, very new, to bring awareness about what we're trying to do. So thank
Yeah.
you very much.
And please come back anytime if you've got any announcements or you want to chat some more. We'd love to have you.
Or if you want to try an implant on Rob, we're all for it.
Sure. Love it.
We got our first user testers.
That's right.
Thank
Appreciate
you very
it.
much, guys. We love that. And yeah,
Yeah, you guys are awesome.
if I can give a shout out
Yeah, please.
to Neil Squire,
Yes.
foundation. I don't know if it's foundation, but he's Squire, especially Tyler Fenty. He was the person that really helped us get started in Canada. So I really love what Neil Squire is doing, and I just want to give them a shout out.
Yeah, we love Neil Squire. We've had them on several times. In fact, I think we've had Tyler on. So all
Perfect.
right, well have a great rest of your day, guys, and
Thank you.
let's stay in touch.
Yeah, for sure. Would
Definitely.
love to.
Okay.
All
Thank you,
right.
guys.
Thanks, everyone.
All right. Thank you both.
All right. Take care.
Bye.
Bye-bye.
Nah, there you go. Look at that small world.
Bum.
Small world.
Mm-hmm.
I mean, I guess there's, in all fairness, I guess there's not all that many rehab organizations around like Neil Squire. So I guess it's not a surprise that they know them well.
Well, they're recognized probably globally.
Sure. Yeah.
Yep.
Yeah. But very cool. It's very interesting to me that that we're starting to hear these about products like this being developed and hearing that the form factor is finally catching up with the potential for wearables. I think we're going to start hearing more and more stories about products like this being developed now that we're finally getting the form factor small enough to really make an impact.
Exciting times.
It is. It is. I can't wait for my implant. Tell you. All right. Well, hey, we should get out of here.
Yeah, it's probably time to go work.
And it's time to go to work. Where can people find us?
They can find us online at atbanter.com.
They can also drop us an email if they so desire at cowbell@atbanter.com.
And they can find us on Mastodon and I guess Instagram. Are we still on Instagram?
Yeah, we are.
Do we do anything on Instagram?
No, we shouldn't have, though. Although we did go out for breakfast there last week, and I did take a picture of my stuffed French toast. So I could probably maybe I'll put that up on our Instagram feed.
Make sure you all tag it.
Yeah, there you go.
There you go.
Okay, I think that's all that we have to say about that.
Yep. Last 8 a.m. show of the year. Woo.
Yeah,
I
phew.
think.
Few. Yeah. Let's not count our chickens. Yeah, you never know. You never know what next week may bring.
That's right.
All right. Well, in any case, that is going to about do it for us this week. Big thanks, of course, to the fellas from Kinemo for joining us. And we will see everybody next week. Moo.
This podcast has been brought to you by Canadian Assistive Technology, providing low vision and blindness solutions, as well as physical access solutions and augmentative communication aids across Canada. Find us online at www.canastech.com, or if you're in the Vancouver Lower Mainland, visit our storefront at number 106 828 West 8th Avenue in Vancouver. That's 1 block off Broadway at Willow. You can reach us by phone toll-free at 1-844-795-8324 or by email at sales@canastech.com.